Hi, in this video, we want to talk about using the formula method to solve quadratic equations. Now, this is the standard form of quadratic equations. Now, what if we try to solve or pretend to solve this equation using the completing the square method? Now, let's try and do that. The first thing we do usually is we move the constant term to this side of our equation. So if we subtract c from both sides of our equation becomes ax squared plus bx equals minus c. And then the next thing we do is to make sure that this coefficient of x squared here is equal to 1. And we do that by subtracting through by a. So our equation then becomes a cancels out a here to leave us with x squared plus b over ax equals minus c over a. The next thing we do is to divide the middle term here by 2 and then square that and add that to both sides of our equation. So if we do that, we have b over 2a squared, b over 2a squared. So our equation becomes x squared plus b over a x plus b over 2a squared equals minus c over a plus b squared over 4a squared. So sidebar, if we have minus c over a plus b squared over 4ac and we solve that, if we have the LCM here is 4a squared. 4a squared divided by a is 4a. Multiplied by minus c, that gives us minus 4ac plus 4a squared divided by 4a squared is equal to 1, and 1 multiplied by b squared is equal to b squared. So this can be written as b squared minus 4ac over 4a squared. So now we know that this part of our equation is equal to b squared minus 4ac over 4a squared. So we can continue. Now we can write our equation as x squared plus b over ax plus b over 2a squared is equal to b squared minus 4ac over 4a squared. So the next thing is to write this in a tighter form of the perfect square. And we do that by opening a bracket. We take our x from here, we take our plus sign from here, and we take our b over 2a from here. We close our bracket and square all that. And this is equal to b squared minus 4ac over 4a squared. Now we can take the square root of both sides of our equation. If we do that, we know that the square root sign cancels out our squared sign here. So this side of our equation leaves us with only x plus b over 2a. And on this side, we have plus or minus. Now we can bring 4a squared out of our square root sign and leave only the numerator under the square root sign. So we have b squared minus 4ac. The square root of 4a squared is equal to 2a. Now we need to make x the square root formula here. And we do that by subtracting b over 2a from both sides of our equation. If we subtract b over 2a from this side, we're left with x. And on this side, we have minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now we have similar denominators here, so we can combine these two to give us the denominator of 2a, and we have minus b plus or minus the square root of b squared minus 4ac. X is equal to this. Now this is the general formula with which we solve quadratic equations. Now let's take some examples and see how we can actually use this formula in solving real quadratic equations. So for our first example, using the general formula method to solve quadratic equations, we have x squared minus 2x minus 6 equals 0. Now the first thing we need to do is identify our coefficients a, b, and c. Now we know that quadratic equations are of the form ax squared minus bx or plus bx plus c equals 0. So if we compare that to what we have, we know that a is equal to 1, yeah, b is a coefficient over x, and that's equal to minus 2. Please don't forget our sign. If we have a minus, it's very important. And c is a constant term here, which is equal to minus 6. So all we have to do now is swap this into the general formula that we have, and then we solve. So this equation then becomes x is equal to minus b is minus 2 plus or minus the square root of b squared. Our b is minus 2 again squared minus 4ac. Our a is 1 and our c is minus 6. And we divide all through by 2a, which is 1 as well. So this becomes x is equal to minus times minus 2 becomes plus 2 plus or minus 2 squared is equal to 4 minus 4 multiplied by 1 is equal to 4, and 4 multiplied by minus 6 is equal to minus 24, all divided by 2 multiplied by 1 is 2. So this is x is equal to 2 plus or minus the square root of 4 minus times minus becomes plus 24 over 2. So our equation becomes x equals 2 plus or minus the square root of 4 plus 24 is equal to 28, all divided by 2. Now we can break this down to make it easier for us to solve. And that's 2 plus or minus 28 is equal to 4 multiplied by 7, all divided by 2. Now if we break 4 out of this square root sign, the square root of 4 is equal to 2. So we can rewrite this as 2 plus or minus 2 root 7, all divided by 2. And if we split this, we have 2 over 2, 2 divided by 2, plus or minus 2 root 7 divided by 2. So this becomes 1, and this cancels out this. So we have that x is equal to 1 plus or minus root 7. And so our two solutions to this equation is x is either equal to 1 plus root 7 or 1 minus root 7. And you can use our calculator to solve that, and we'll have that x is equal to 3.646 or minus 1.646. And those are the two roots of our equation. So let's solve our next example. So we have another example here. And if we compare that with our standard form of quadratic equation, we have that A is equal to 2, our B is equal to minus 10, and our C is equal to 3. So if we insert these values into our general equation, we have that x is equal to minus b, which is minus 10, plus or minus the square root of b squared, which is minus 10 squared, minus 4 multiplied by a here and multiplied by c here. And we divide all through by 2 multiplied by a. So this becomes minus times minus 10 equals 10, plus or minus the square root of minus 10 squared is equal to 100, minus 4 times 2 is 8, 8 times 3 is 24, and we divide all through by 2 times 2, which is 4. So our x equals 10 plus or minus the square root of 76, all divided by 4. So this becomes 10 plus or minus. Now we can rewrite 76 to make it easy for us. And that's equal to 4 multiplied by 19, all divided by 4. So now we can bring 4 out of our square root. And this becomes 10 plus or minus 2 root 19 divided by 4. So here we can split up our equation, and x is equal to 10 over 4 plus or minus 2 over 4 root 19. Now 2 can cancel out this to have 5 over 2, plus or minus, here 2 cancels out 2 and we have root 19 over 2. So x is either equal to, we have a common denominator here, which is 2. So 5 plus root 19, or 5 minus root 19 over 2. And we can solve each of this with our calculators. We have x is equal to 4.6795 or 0.6795, and these are the two solutions to our quadratic equation. And that's how we use the general formula method to solve quadratic equations. It's quite easy. All we have to do is bring out our coefficients a, b, and c and substitute that in the general formula, and then we solve as we've done for the previous two examples. Please don't forget to subscribe. I'll see you in the next video. Bye.